All right, so I want to do something. This is what this thing is all about. You know, when you add rational numbers, that is fractions. And here we're going to add rational polynomials. So it's a polynomial divided by a polynomial. Right, Whitney? Mm-hmm. Okay. So we're going to do example, if it's a rational number, it's 1/6 plus 1/9, if we wanted to add that. Now this is the process that we're going to go through in this to do that. Now you could probably do this quick, but you prime factor each denominator. So this is 2 times 3, and 9 is 3 squared. Then what you do is you build the least common multiple of the denominators, or else you call it the least common denominator, whichever way you want to call it. It's the least common multiple of the denominators or the least common denominator. And you build that, and you say, this denominator has a 2 and a 3 in it, right? This denominator has a 3 squared, so you must have a 3 squared. Now what you did is you looked at this denominator and I'm just going to rewrite it. You have this thing that looks like this, and this one that looks like this, right? And you look at that first one and you say, and then you compare it here, and you say, what I don't have is another 3. So you multiply the denominator by 3, and in order not to change the fraction, you go 3 over 3, because 3 over 3 is 1. Now then our denominator is what? 2 times 3 squared, right? This denominator, when you compare it to here, lacks a 2. So you say, I need to have another 2 in that denominator, and I've got to go 2 over 2 so I don't change the fraction, right? That's the process. Then what we're going to do is the same process, except we're going to do polynomials, prime factor polynomials. Then you went this way. You said, okay, this denominator right here, and this one is the same. So you said, I have 2 times 3 squared, and I'll write it down once, and then you write the numerator. 1 times 3 is 3. You bring this sign down in between, and then 2, and then you do whatever you're told to do in the numerator, which is 5, right? And then this thing becomes 5 over 2 times 3 squared. We're going to do that same thing, except we're going to have polynomials in the denominator. Do you understand? That's all it is. Now then, the way this thing is divided out is, first of all, on objective A, they're giving to you a couple of terms, and you are to think of these terms as if they were denominators, and you want to find the least common multiple of those two. And that's, you understand what it is? Then you're going to practice. In the next thing is you're going to practice getting the least common multiple of the denominators and building the fraction, not doing anything to it. And then the next objective C is, when your denominators are the same, practice what you do with the numerators. And then objective D says, now you have to build the least common denominator, build the fraction, combine the numerators, and then simplify. It's just the process they're having you go through in order to learn how to do things. So each one of these things, although they look independent, are really building toward what you want to do in D. Do you understand that, what I said? Okay. Now then, Whitney, tell me where to start. 24. So what we have is x squared plus 7x plus 10. And then x squared minus 25. So in essence, you're just saying, okay, this is what we're pretending. Those two are denominators, and we're going to find the least common multiple of them. The first thing you have to do is prime factor those. You got to prime factor them. So we're going to prime factor the numerator. And what you do is you say that numerator is polynomial descending order, leading term is positive, no common factors, because we're trying to factor it. And then you say it's a trinomial, not a special case. If it factors, it's going to factor as a pair of binomials over the integers, right? So then you go x, and the plus sign on the constant term says same sign. That tells you it's a plus sign. Being they're both plus, then you say what two numbers times itself is 10. When you add them together, you get 7. What are they? 2 and 5. So now this one is now prime factored. Now the x squared minus 25. It's descending order, leading term positive. No common factor. It's a binomial, and it's a binomial what? Difference of squares, isn't it? X squared and 5 squared. Now the algorithm says when you have a difference of squares, it factors into x plus 5, x minus 5. Now, each one of those terms is prime factor. You agree? Now you want to build the least common multiple. That is, what what number are both of those numbers a factor of? So what you do is you go to the numerator and you see it. You say this least common multiple must have the prime factor x plus 2 in it, and it must have the prime factor x plus 5 in it. And if it has those two, then that numerator can be divided into that least common multiple. Right? Then you go down to the denominator and it says it has to have an x plus 5. It's got an x plus 5. It says it has to have an x minus 5. Don't have it, so you add it to it. Now, you say this then is the least common multiple of those two numbers. It's the number that both of those will divide evenly into. Does that make sense? So you prime factor the terms, and then you build the least common multiple from each one of the prime factors to the highest power that occurs in either one. All right, that's 24. What's the next one? I can see another one that I would want to do just to make sure you know how to do it. But does anyone have, in working the problems, have you had trouble with any of those? Beyond that, how many have tried the problems? No one. Okay. Have you tried the problems, Whitney? No. Well, I'm just taking a shot in the dark. Do you see 29 and 30 are alike in that what? They are not written in descending order, and if you write them in descending order, the leading term is not positive. Do you see that? Do you see that? I mean, that's a problem that maybe would present itself. Do you want me to do, before I do 30, do you want me to do anything prior to that? Now 30 is what I'm going to do. 30 says you've got to term 15 plus 2x minus x squared. And then you got to term x minus 5. And you got to term x plus 3. Now, in order to find the least common multiple, what you need to do is you need to have every one of those terms written in descending order, leading term positive. Well, this one, right here, that first one, is not in descending order, and it would not have the leading term positive the way it is, right? You see, if I wrote it in descending order, you have a minus x squared plus 2x plus 15. But now then your leading term is not positive. And you always do the leading term positive. Does that make sense? Now then, how am I going to get the leading term positive? A negative sign out, right? So I can factor a minus 1 out, and now you have an x squared plus, no, minus minus 2x minus 15, right? Now, that's not prime factored yet, is it? It's a trinomial descending order leading term positive. I got it that far. It's no common factor. It's not a special case trinomial. So what I have to do, if it factors, it's going to factor into a pair of binomials with x and x, and the sign is going to be what? Plus and minus? Now the question is, what two numbers multiplied together give me 15 who, when I take their difference, give me 2? 5 and 3, right? Now, what has to be negative, the 5 or the 3? The larger number, right? In order, that's 5. Has to be negative. Now then, this is the prime factorization of this term right here. So when I build my least common multiple, it must have a minus 1, right? It must have a x plus 3, and it must have an x minus 5. Now, I look at this one, it says it has to have an x minus 5, it already does. I look at this one, it says it has to have an x plus 3, it already does. That's my least common multiple. That's what you have, that's what you have to do. And just remember that when you have to write these things, there's other ways that you can figure it out, but if you don't do it so that you have your polynomial descending order leading term positive, it is really difficult. There's nothing to say you can't factor this thing, but then your factors will be off, and you might think you have more factors than what you need. Does that make sense? If you just follow, I've laid out an algorithm that if you follow it for most of the time, it will fall out as to what you have to do. You want to see another one on that page? That's good. Okay, now the next page is you're going to find the least common multiple of the denominators and then build the fraction so that both of those rational polynomials have the same denominator. So this is what it's going to amount to, 34. So the first rational polynomial you have is 4 over x. And the next one you have is 3 over x squared. Now, what you want to do is you want to find the least common multiple of denominators. Or you sometimes call it the least common denominator, whichever way you want to call it. They're calling it the least common multiple of the denominators. The first thing you want to do is make sure that each denominator is prime factored, and it is. Now then, you take the first denominator and you take every prime factor to the highest power that it is, and it occurs in that denominator. And the first one is x, it's only to the first power. The second one is x squared, so x squared is the least common denominator, or least common multiple of the denominators. Now what they're asking you to do is build each denominator so that it is x squared. So you compare this with this right here. It lacks an x. So what you need to do is you need to have another x in the denominator. Now, in order to not change the fraction, you got to go x over x, right? Because x over x is 1, isn't it? That does not change the fraction, but it gets you to a squared term in the denominator. So that this fraction now, 4x over x squared, is equivalent to the black number, this number right here, but it'll have the same denominator as this one. And that's all you're practicing in this set. So let's look at, now sometimes that second one, this one, you have to change and get the denominator to the least common denominator, and that'll come here in the next one or so. 38. Did I go too quick? So I have a y over x times x minus 3. And then I have a 6 over x squared. Now first you look at, you say, are these denominators prime factored? Are they? Nothing more that can be factored, right? So now build the least common denominator, and that's what I'm going to call it. Now you take the first denominator, this one, and everything, every prime factor to its highest power that occurs in that denominator, you put it over here. Now you go to your second denominator, and then you say there has to be an x in this denominator, but it has to be the second power. And notice it isn't, so you add it to that power. Now then, this is the least common denominator. Now what you want to do is build each one of those fractions so that it has the same denominator, least common denominator. You look at this one, you look at this, and you say what it lacks is an x. So if I were to multiply an x by it, it would be the same as the least common denominator, and I have to go x over x so it don't change it. Now then, this one right here, you compare it to there, and that lacks an x minus 3. I would have to do x minus 3 over x minus 3. Now what would that fraction look like? This one would have x squared times x minus 3 in the denominator. And its numerator would be xy, right? This one would have a denominator of x squared times x minus 3. And it's going to be the same as this because that's what our goal was. And it's going to have 6 times x minus 3. Now, when you start dealing with the problem, you might want to distribute this out in the numerator and write it as 6x minus 18. My suggestion is don't distribute this out until you get completely done with the problem. Because you might find that when you get to the end, there's a common factor, numerator and denominator, that you want to cancel. When you start adding the rational numbers together or subtracting them, and so on. As far as I'm concerned, writing it like this is fine in terms of an answer. Okay, 38. Let's look at 46. We have a 3 over x squared plus 2x. And we have a 4 over x squared. Now, this denominator, is it completely factored? Aaron, you're shaking your head no. What would you do with that?
No, you know, I was kind of just guessing on that one. I don't know that one.
Okay. This is where you just use your algorithm. You go through it. You say, is the polynomial descending order leading term positive? It is, right? Then you say, is there a common factor? What is it? You have an x squared and a 2x. Is there common to those two? An x. So you take an x out and you have x plus 2. Now, does that look like there's anything more that can be factored? No. Do you see what I did? I just used my algorithm and figured out what it is. I wrote it in descending order, leading term positive, and then the next thing it said, is there a common factor? And I did it. And then I looked at it and I say, you know, there's nothing else that I can do with that. I can see that. Does that make sense?
Yeah.
Now then, this one, is that completely factored? All right, so we have the two denominators completely factored, right? Now then, we're ready to do the least common denominator. And you go to your first denominator, and every prime factor that's in there has got to be in the least common denominator. So you just put these two over there. That's the easy thing, right? Just take everything in the first prime factorization over. Now then, you look at this denominator, and you look up here and you say, am I lacking anything? This says I have to have an x squared. Do I have an x squared over here? Well, then what do I got to do? Put it in, right? So I got to go x squared, right, like that. I only have one x, I want two x's, right, multiplied times each other. Now then, nothing else, I've got my least common denominator built. Does that make sense? Okay. Now then, the next process is, you can either use this and this to build it, or else you can say, I'm going to write that first one in the denominator's prime factored form. And then I'm going to write this one down just because, and it's prime factored. Now then, does my first denominator lack anything when I look at it at the least common denominator? This has an x to the first power, this one down here, an x to the first power times x plus 2. This one has an x squared times x plus 2. Does this one lack something to make it least common? Does no one see it? It lacks the x squared, don't it? What would we have to do with this one to get the x as a square? another x, right? So I'd have to put another x in this denominator, and to avoid changing the fraction, I have to go x over x. Now please say that you understand what I just did. Do you understand? Now then, look at this denominator and compare it to this one up here. What is missing?
X plus 2.
An x plus 2, so I'd have to put an x plus 2, and then I have to do a numerator x plus 2, right? What you would do with this is you would write this as 3x over x squared times x plus 2. And then you'd write this as 4 times x plus 2 over x squared times x plus 2. Generally, these denominators, once you get them in prime factored form and you manipulate them, you leave them alone. Oftentimes, what you'll have to do is you'll have to distribute the things in the numerator. Because you'll have to be doing some things with the numerator. In terms of what I'll take, this is fine with me. Because until you get into a problem, you don't really know what you're going to have to do with that numerator. I mean, a specific problem. So, let's see. $46. Do you? We can try 54. See what that is. That's one of the harder ones. So the first term is x over x squared plus x minus 6. And the second one is 2x times x squared minus 9. Now, look at this denominator. It's written in descending order. Leading term is positive. No common factor, right? It's a trinomial, not a special case. So if it factors, it's only going to be trial and error over the integers, right? Pair of binomials. It's x, and the signs are what? What does this tell us? Opposite sign. Now, two numbers times itself is 6, whose difference is 1. Two and 3. Now, which one's positive? The 2 or the 3? The 3 is positive, because the larger one has to be positive to get that positive. Now, notice that trinomial is prime factor, right? Now then, look at this one. That says it's a polynomial, descending order, leading term is positive, no common factor. It's a binomial. A binomial, you got those 4 different situations. Sum of squares, difference of squares, sum of cubes, difference of cubes. Does it fall into any one of those 4 categories? Difference of squares, right? It's an x and a 3. So that factors into what? X plus 3. X minus 3. Right? Now that each one of our denominators are prime factor. Now we're ready to do what? Least common denominator. Now our first denominator we look at, we just take all of those prime factors over, right? X plus 3, X minus 2. Now in the second one, when we look at it, we have to see whether all of our prime factors are in there. This one says an X plus 3 must be in it. There is an X plus 3. We don't need to take anything more over, right? This one says there better be an X minus 3. We look up here, no X minus 3. So what do we have to do? Add the X minus 3. Now every prime factor to the highest degree it occurs in each one of our denominators is in the least common denominator. Now what I'm going to do is I'm going to rewrite this thing as written over the top of its prime factor denominator. And the same way with this one. Now, compare this one with the least common denominator. What do I lack?
X minus 3.
An X minus 3. So I'd have to multiply the denominator by X minus 3. And then the numerator by X minus 3, right? What's this denominator lack? X minus 2, don't it? So we have to do an X minus 2 and then an X minus 2. So now what I want to do is simplify this thing. The denominator here is X plus 3, X minus 2, X minus 3. It's the same as the least common denominator. The numerator is X times X minus 3, right? This one, the denominator is X plus 3, X minus 3, and X minus 2. Community property of multiplication says, that's the same as the least common denominator. The numerator is 2x times x minus 2. Does that make sense?
Okay. Now, the next one is it says
When your denominators are least common denominators, what do you do with the numerators? So you see how we're just practicing along, finding the thing. So what do we do with the numerators? So I'm going to do 58. And this says 6 over AB minus 2 over AB. Now notice the denominators are the same. And that's what this whole objective C is going to be. Their denominators are always going to be the same. So what you do is you just put a common denominator AB. Then in the numerator, you go 6 is the numerator for the first term, and then you bring this term, right, this sign right down here. And then 6 minus 2 is 4 over AB. You simplify your numerator. And that's the answer. Now look at 62. It says 6y over 4y plus 1 minus 11y over 4y plus 1. Now when the denominators are the same, you simply draw a long line, put the single common denominator underneath. Then you take the numerator, 6y, bring the sign that's between the two rational polynomials down, minus 11y. You simplify that. That's what? Minus 5y in the numerator over 4, is that a y or x? That's a y. 4y plus 1. And that's your answer. Okay. Now do 66. It says 6x minus 5 over x minus 10, then minus 3x minus 4 over x minus 10. Now once the denominators are the same, you write x minus 10 single denominator. Now in the numerator, 6x minus 5. I could put a bracket around there, but do I need to? No, because the signs are not going to be changed. But now there's a minus sign that comes down here. Now, this line acts as a bracket of that numerator. I had better bracket that, right? Because that sign is going to change it. Now, my numerator is 6x minus 5. This says opposite every sign inside that bracket, minus 3x plus 4 over x minus 10. Now the numerator, combine like terms. We have 3x minus 1, x minus 10. And there's my answer. And do 70. It says 3x over x squared plus 3x minus 10 minus 6 x squared plus 3x minus 10. Now notice we have a common denominator. Write it down, x squared plus 3x minus 10. And then the numerator, 3x, that minus sign comes down right there, and that's a minus 6. Now then, what I need to do is I need to factor that numerator. It's polynomial descending order, leading term positive. Is there a common factor? Yes. 3 comes out, and you have x minus 2. Right? Denominator. That's a polynomial descending order, leading term positive, no common factor. It's a trinomial, not a special case. Does it factor? Well, if it does, it's a pair of binomials with an x and an x, and the signs that are what? Plus and minus. Two numbers times itself is 10, whose difference is 3, is what? 5 and 2. And the 5's got to be positive, and the 2's got to be negative. Now then, look at this numerator and this denominator. Are there common factors? X minus 2, right? These two are the same, they cancel. So now then, I have a 3 in the numerator and an x plus 5 in the denominator. See that? See how they did? It just progressively gets new stuff and harder stuff. But you just got to do the same process over and over again. Now what we're going to do next time is we're going to do objective D, and that is finding the least common denominators, combining the numerators, and then simplifying the problem. So it's putting everything that we've done together, right? So that's